So one of you asked, how do we know when we need to add a stretch or compression to a equation to describe a graph or a function to describe a graph? So this is where you got to have an idea of how the functions behave, and those toolkit functions we talked about. What are there, 12 of them or so? You got to remember how those work. So for this example, I did a quadratic, an x squared, right? And the blue dotted line is the x squared one. That's just the basic. That's the toolkit function. And then I added a vertical stretch of 2 to the equation. So how would I have known to do that just by looking at the graph? Well, I know. Here, let me get a pointer going. Um, when I go for x squared, if I go over 1, I go up 1. If I go over 2, I have to go up 4. But with this red graph, when I go over 1, I'm going up 2. When I go over 2, I'm going up 8. So you see how the y value is getting doubled? So that tells me I have to have a 2 in front of it. Of course, you can see that I did. Okay, same thing happens. Well, what if it's a vertical compression? Let's put that down to 1/2. Okay, when I go over 1, I'm only going up, I don't know, maybe a half. But when I go over 2, I see I'm only going up 2. So that's a nice lattice point. So that tells me, and remember, it's supposed to be 4. So that's only half of what it should be. So that tells me I have to have a 1/2. So I would be writing 1/2 x squared, right? So that's the vertical compression. And then, of course, you know about the flips right around the x and y axis. So we won't do that. But so think about what the toolkit function is going to do, and then what does it look like? So again, let me just do this. Let me just turn this off. Let me do a square root of x. I like dealing with square roots when I'm thinking about transformations. Let's see, here's square root of x. So this is going to be the toolkit function. Whoops, Dan, let's do this. Make it dotted. Okay, and then now I'm going to do a here. Let's see, can I do this? I think I can. Let's see if I can just type this in. ASQRTBX. Yeah, there we go. Yeah, I'll even get rid of that extra parentheses. I don't need it anymore. So the leading coefficient's 1/2, and you see now when with quadratic equation or a square root function, when the square root of 1 is 1, the square root of 4 is 2. For this one, when x equals 1, y is less than that. So in order to get to 1, I've got to go all the way over here to 4. And see how it's only going up to 1? So that tells me it's supposed to be 2. So that's the y values are half as big. So that tells me that's a vertical stretch, a vertical compression by a factor of both. We would write it as 1/2 here. Do I get a board here? Let me see if I can write. So I would write y equals 1/2 the square root of x. Where was I going with that? Yeah, I don't know. I don't remember what I was just thinking, but that's what I would write for that red graph. And again, if we moved it up to, we can. I don't know if you probably already have this, but let's make A be. Oh, let's make A be 3. See if our graph will fit. Whoop. Whoop. Come on, Dan. There we go. So when x equals 1, it's supposed to be 1, but now when we go to 1, it's 3. So that tells me the leading coefficient now has to be 3. Of course, we knew that because that's what I made it be, but that's how you can tell what it needs to be. Now, the other thing that arises is these horizontal stretches and compressions, and those are tricky. I struggle with those. So in the book, they talk about how if you have f of bx, right, where b is inside, that's going to be some kind of horizontal compression. It's going to be, if b is bigger than 1, That's going to be a horizontal compression by factor. I mean, you could say, I mean, usually what it says in the book is take it, put it 1 over b. So if b is bigger than 1, so it would be let's say, well, let's do this. I already do this. A is 3. No, let's make a be 1/2. Or let's make b be something here. Let's change a to 1, or a to 1. I want 0. Oops. Oh, come on. 1. And then b, let's make b be 1/2. And I don't want negative. Come on. Okay, there we go. So do you see how it's not growing as fast as it was? So it's being stretched out further in the x direction. So what I want you to come out of this, well, isn't a horizontal compression or a horizontal stretch the same as a vertical compression? It is. And you can rewrite it that way too. My open math is going to be looking for if it gives you a number b, it's going to want to talk about horizontally. But that isn't to say that you just, for a lot of functions, you couldn't just say, okay, I know that this is going to be the square root of well, this is 1/2. I was going to make it be 2. Okay. If we make it 2, I should be growing faster. That's confusing, Dan. Let's make b be 2. Well, actually, let's just do this. Let's make this be 1/2. Come on. And I'll just graph the square root instead of having to fool with the sliders. The square root of 2x. See how that grows faster? So then that's a horizontal compression. See that? And this is a case. See, this is a case where b is bigger than, right? Where b is bigger than 1. So that's going to be a horizontal compression by a factor of 1/2. It takes, in order to get to 1, right? In order for this blue curve to be y equals 1, that's going to happen at, well, it's going to happen at 1/2, right? But think about it. Let's pick another, that's guesswork. Let's pick another number we know. When x equals 2, it says y is 2. Well, that shouldn't be happening until 4, right? So see how it's compressed this way? It's compressed horizontally. So if b is bigger than 1, it's going to be a horizontal compression because it's growing faster. It's acting like when x equals 2, it's acting like 4. X equals 4, right? So that's why we know it's going to be the square root of 2x. Come on. So I think, so the original question was, how do I know when I had to have a stretch or compression? Well, these are the things you got to do. Think about what the base function looks like, and then the toolkit function looks like, and then ask yourself what's happening to the y values. And if it's taking longer, if it's growing faster, you can talk about it as a vertical stretch or horizontal compression, depending on what they're looking for. Okay. Well, how can I write? I left off that. I didn't finish that thought. And let me do it. I'm sorry, it's a little rambling here, but I can always write what if I wanted to write the square root of 2x? And so instead of being a horizontal compression, I wanted it to be a vertical stretch. So one with a square root, what we can think of is, if you think back to some stuff you might have learned in geometry or maybe algebra 2 or college algebra, when I'm multiplying two things underneath the square root, I can think about as it the product of the two radicals. And here is the vertical stretch, because the square root of 2 is 1.4 blah 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 blah. So that's bigger than 1, so that's going to be a vertical stretch. Same thing if I had 1/2 x squared, right? That can be thought of as Well, let's see. When I'm multiplying, when I'm raising things inside to a power, isn't that the same as 1/2 squared times x squared? So that will be 1/4 x squared. Okay, let's make sure let's make sure I'm not wrong, or that I'm not just blowing smoke here. Let's see. Let's see. So I said A is 1/4. A is 1/4. Whoop, not negative, Dan. Well, let me do, I can't do here. Let's just do it won't let me do what 1.25. So that's the base. That's going to be the base. Let's undo that. Let's undo that. Let's undo that. So that's the base. And then I'm going to do this. Let's make this be 1/4 x squared. So 1 divided by 4. Did it take that? Let me turn that on. A is 1. Oh, B is, I get B. B isn't 1. There we go. So do you see how this is that's a horizontal, that's going to be a horizontal, it'll be a vertical compression. Let's see which one's dotted. Okay, let's do this. Let's just make that be solid now. Come on, blue. Okay, I don't want to be dotted. I want to be solid so I can tell the difference. Here we go. So the red graph is x squared. The blue graph is what? 1/4 x squared. And let's make this be, let's see. What if we do the two things? What if we do 1/2 x squared? Should be the same graph. See how the green graph and the blue graph are exactly the same? So that's how I rewrote that horizontal. Stretch as a vertical compression. So you can always do that by pulling it out of the function, if it's possible. Some things just don't work well that way. So, I mean, it's a bigger pain to do it than to think about it horizontally. Okay, I hope this answers your question. I hope it helps you understand that horizontal stretch and compression a little better. And try some problems out of the book, and I mean, you can do my math too, but there's a limited number of those. Of course, there's a ton in the book that we can post and look at in the forums. Okay.